Hi everyone, today I'll be talking about standard form, and standard forms is just another way for us to write numbers. It is especially useful when numbers get very big or very small. So for example, we have 299, 000, obviously that's a very big number. And now we could also have a 0.000005. Obviously, there are a lot of zeros in between the decimal point and the 5. Sometimes you can get even more zeros, and so therefore that will be a very very small number. So we use standard form in order to so-called simplify the way we write the number. So let's look at how we write numbers in standard form. So the format in which we write the standard form consists of a, which you can call it or think of it as the front number, times 10 to the power of n. So there are certain conditions to all these things, and so do pay attention to this part. The power n must be an integer, so that's quite straightforward. It cannot be powers like half or 3.5, for example. And the front number a has to be between 1 and 10. It cannot be a 10, right? But it can be more than or equals to a 1. So we're going to look at some examples versus some non-examples for us to distinguish between numbers that are written properly in standard form versus numbers that are not written properly in standard form. So let's look at some examples. So the four examples we have over here, and let's look at the front numbers for each of them. The first one is a 2, followed by a 3.14. It's a 1 here, and then a 9.999. All of them are fine, all right? Even if you talk about the third example here, where it's a 1, it's fine, all right? A can be more than or equals to 1. The last one is a 9.999. I deliberately give this example, but clearly this is less than 10, so it is fine. All right, and just to quickly look at the powers of 10. The first power is a 5, followed by a -2, a 16, -3. Negative integers are fine, they are still integers, so long as they are not like 1.5 or 1.75, the kind of thing. So that's all right. So some non-examples are 74 times 10 to the power of 8. Obviously, this one, the problem is 74 exceeds 10. It's not even, is way more than 10. All right, so this is not correct. So of course we can rewrite this in standard form, and I'm not going to talk about that yet, right? So the next one will be a 0.2. So this is less than 1, so that's not allowed. The front number is obviously the problem. And a third example, likewise, the front number is the problem, and it's 10, so it cannot be a 10, it has to be less than 10. So obviously, this one can also be rewritten in the standard form, but again, not going to explore that for now. Right, and then the last one is 2 times 10 to the power of -1.5. So as mentioned, the powers of 10 has to be an integer, right? So this is obviously not an integer, and that's not okay. So in example 1, we are asked to convert two standard form into ordinary numbers, which in the question it says ordinary notation. And in part A, we have 6 times 10 to the power of 3. So think of 10 power 3 as 10 times 10 times 10. And that's going to give us 6,000 as our final answer. And we can do this conversion by using our calculator. So the steps are there just to help you understand how it comes about. And 6 times 10 to the power of 3 indeed gives you a 6,000. So in part B, we have 5 times 10 to the power of -2. So recall that 10 power -2 is the same as 1 over 10 to the power of 2. So that's applying the concept of negative indices. And so therefore we have 5 times 1 over 100. Another way of looking at this negative powers of 10 is that we are actually looking at how many times we divide by 10. So in here, if we have 5 times 10 to the power of -2, that means we are actually dividing 5 by 10 two times, right? So that's the general idea. So we also obviously can use a calculator to help us to do that. And so therefore we have 5, right, times 10 to the power of -2, and that's going to give us 0.05. Next, in example 2, we have two ordinary numbers where we're supposed to convert them to standard form. And these two numbers are obviously taken from example 1's answer. And we're going to see whether we can get 6 times 10 to the power 3 and 5 times 10 to the power negative 2. Right, so let's look at example 2a first. So we have 6,000. And we know that the front number is supposed to be a 6. Right, so it's 6 times 10 to the power of something. Right, and next we can introduce a decimal over here. So you can actually write it as 6,000.0, right? It's just that in general, most cases we don't write that because there's no context, or if you're not asked for it, then there's really no need to write 6,000.0. But for us here, the decimal point actually helps us to consider how do we get that 6. All right, and so let's think of it as I'm shifting the decimal point to the left. All right, and we stop over here, then we have a 6 point, a 6.0, but we have a 6 point. So so we move the decimal point to the left, and we moved it by 3 times. And so we write the power as 3. Okay, next we will look at the second example, or rather example 2b, and we have 0.05. We know that the front number is supposed to be a 5 times 10 to the power of, and because this is in the category of smaller numbers, we're going to put a negative first, and the decimal point is going to be shifted to the right until after the 5. So we get 5.0, for example. So we have a 5. Then the number of times that we shifted right, by 2 times, we will leave the power as negative 2. Okay, so next we will look at some examples, and you are welcome to pause the video first and try it on your own. Take a piece of paper, try it on your own, and before you play the video to check your answer. So next, in example 8 on my screen, we have a few numbers where we're supposed to convert to the standard form. So let's look at example 8a and 8c first. Alright, so in example 8a, I'm going to introduce a decimal point here. Alright, and again, same thing, I'm going to consider how many times I have to shift this decimal point. So I have 6.12 as my front number. I cannot leave out the 12 times 10 to the power of certain number. We'll fill that in later. So we're going to consider how many times we have to shift this decimal point. So I'm not going to draw arrowhead so many times, so I'll just do the arrows without the arrowhead. So it's going to look like this. So I'm going to shift this decimal point 1 time, 2 time, 3, 4, 5, and 6. So here is where my decimal point would land. So I've counted a total of 1, 2, 3, 4, 5, 6 times. So the power of 6 for the 10. Right, so it's going to give us 6.12 times 10 to the power of 6. Right, next we have 11.04. This is not exactly a very big number, but still in terms of the skill of converting to standard form, it works like this. Right, so we know that our front number is supposed to be 1.104, and our decimal point only needs to be shifted 1 time. So it's times 10 to the power of 1. Next, for example 8b and d, alright, these are in the category of small numbers, so bear in mind our decimal point will be shifted to the right, as well as the power of 10 will be negative. So for part B, my front number is supposed to be a 9.2, and my decimal point has to be shifted 1, 2, 3, 4, and 5 times until it reaches after the 9. So it's 9.2 times 10 to the power of negative 1, 2, 3, 4, 5. Okay, so that's 9.2 times 10 to the power of negative 5. Right, next we have 0.523, and again, this is not a very small number, so we're going to just look at how do we convert to standard form and the scale of it. So we know that this decimal point has to be shifted to the right 1 time, so it's 5.23 times 10 to the power of negative 1. So in example 9, we can actually just use a calculator to compute each of the parts. So in part A, we have 4.25 times 10 to the power of 4, and we're going to get 42500. And next we have part B, we have 3.14 times 10 to the power of -6, and we're going to get, oh, we need to be careful about this, 0 point, and you're going to count 1, 2, 3, 4, 5 zeros, and 314. Right, and in part C, we have 7.88 times 10 to the power of 6, and we have 788, and again, do be careful and count the number of zeros, so there are 4 zeros over there. And then lastly, we have 2.45 times 10 to the power of -5. Alright, so again, count the number of zeros after the decimal point. You have 1, 2, 3, 4 zeros and a 245. So that concludes this video on standard form. This is just a very basic introductory video. So thank you for listening to me explaining standard form, and I hope you are able to do questions in terms of how to convert ordinary numbers to standard form and vice versa. Right, thank you and goodbye.